Okay, here come your notes for day 7. Today all you need to do is watch this video, and tomorrow you'll get practice on problems. Tomorrow's problems are page 761, and then there's, it looks like 9 problems. So what we're going to be doing today is plotting inequalities. The 4-step process is: first, you need to plot some points, and this is going to be a review of how to plot lots of different functions, which is good because we have an exam coming up. Second, you've got to determine whether your line is going to be dashed or solid. And if you look at the inequality symbol, if there is no equal sign, you're going to have a dashed line. And if there is an equal sign, you're going to use a solid line. Third, you're going to pick a point to test. Now, it's usually going to be 0, 0, but every once in a while, 0, 0 doesn't work, either because it's on the line or because 0 is not in the domain of your function, so you'll use a different point. And then finally, if you wind up with 0, 0 being false, you're going to shade the other side of the line, like what's shown here. Or if 0, 0 is true, you're going to shade the side of the line with 0, 0 on it. So let's go through some examples. The first one, we have 2y minus 5x is less than 10. If you imagine that that less than is an equal sign, that's just a straight line. And instead of solving for y, finding the two intercepts is a little bit easier. If you plug in 0 for x, 2 times 5 is 10, so that's why y is 5. And if you plug in 0 for y, this term here disappears. Negative 5 times negative 2 is 10, so you get negative 2. Plot those 2 points. 0, 5 is right there. Negative 2, 0 is there. I saw that the slope was down 5, left 2, so I got a third point by going down 5, left 2. I'm going to test 0, 0. When I plug 0, 0 into this inequality here, we wind up with 0 less than 2. That's true. So since 0, 0 right here is true, I'm going to shade this side of the line. Example 2. The inequality has an equal sign, so it's going to be a solid line. A quadratic is a parabola. Instead of factoring, which doesn't work to find the roots, I'm going to find the vertex. Negative b over 2a is the vertex formula. Get 1, plug 1 in. You get y is negative 6. Your vertex is 1, negative 6. Over 1, down 6. For quadratics that have a coefficient of 1 in front of x squared, it's over 1, up 1 times 1 squared, over 2, up 1 times 2 squared, and over 3, up 1 times 3 squared. These 1s are because the coefficient in front of x squared is 1, and then the pattern is however many you move over, you square that. So I get 1, 4, 9. So from the vertex, over 1 in either direction, up 1. From the vertex, over 2 in either direction, and up 4. And from the vertex, over 3 in either direction, up 9. And you get this parabola. When I go to test 0, 0, which is right here, plug it in. You get 0 is greater than or equal to negative 5. That's a true statement. So since 0, 0 is true, everything on this side is true. You can see near my blue line, I did little shadings towards the true point, 0, 0, and then I went back and filled it in with the red. The third example deals with the circle. The format for a circle is x minus h squared plus y minus k squared equals r squared. So if I match those up, 1 is h, negative 2 is k, because the plus sign means I got to change it to a negative 2, and 16 has a square root of 4. So I'm going to plot a circle at 1, negative 2 center and radius of 4. 1, negative 2 is right there. Go right 4, up 4, left 4, down 4. Those are 4 points on my circle, and then I tried to draw a reasonably shaped circle. Same process, test 0, 0. When I plug in 0, 0, I get negative 1 squared, 2 squared, and 16. Is 5 greater than 16? That's false. So 0, 0 plotted right here is false. I'm going to go to the line and shade the other side. So outside of the circle is all of this area here. The final 2 examples deal with exponentials and logarithms. We're going to be plotting a solid line because the inequality has an equal sign, and I've decided I'm going to start with 3 to the x and move it right 1. So in yellow, the exponents of 0, 1, 2, and 3 produce 1, 3, 9, and 27. And if I were to plug in negative exponents, I'm going to get 1/3, 1/9, and 1/27. So for an exponential, when you plug in 0, you get 1. When you plug in 1, you get 3. If you plug in 2, you're going to get 9, which is off the scale. So I'm backwards instead. If I plug in negative 1, I get 1/3. After I do that, I want to move all those yellow points right 1 unit. That's a transformation. If you have addition or subtraction inside the function, it's left or right. So pick up all 3 yellow points, move them right 1 unit, and this blue line represents y equals 3 to the x minus 1. There's an asymptote over here, so there's the exponential. Testing 0, 0, it's not on the lines. When I plug 0, 0 into the original, I get 0 is less than or equal to 3 raised to the negative 1. Anything to a negative exponent means reciprocate. So is 0 less than or equal to 1/3? Yes, that's true. So for my point 0, 0, it's a true statement. I'm going to shade everything on the same side of the line as 0, 0. So everything down here gets shaded. The final example uses logarithms. Log base 2 of x can be plotted this way. Logs is one of the few cases where you actually pick values for y and then go back and figure out values for x. So if I pick 0, 1, 2, 3 for y, that means my x values are 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. Gives me these ordered points. If the pattern is that every time the x-coordinate goes down by 2, I can go backwards, cut 1 in half, and then the y-coordinates go down by 1 and get negative 1. So 1/2 negative 1 is an additional point, and then cutting x down by half again, I get 1/4, and reducing the y by 1 gives me negative 2. So I plot all these points. I have 3 of the 4 blue ones plotted, and then the 2 green ones plotted, and that reminds me that there's a vertical asymptote at the y-axis for log graphs. That means you can't plug in a negative number to a log plot. It also means you can't plug in 0 to a log statement, so I can't test 0, 0. So the next best point would be 1, 1. If I take 1, 1 and plug it in for x and y, the log of any base of 1 is 0. Is 1 greater than 0? That's true. So at the point 1, 1, which I tested, I get a true result, which means I'm going to shade all of the stuff above the dashed line. I have to stay to the right of the y-axis, however, because no part of the log graph can go with negative inputs. So everything to the right of the y-axis and above the log line is the final solution. Okay, that's it. That should be enough to get you through the homework. Good luck.